Okay, we'll start in about 1 or 2 more minutes time. Okay, let's get started. All right, presume all of you have done your tutorial, so let's start with question 2. Okay, question 2 says that the height and weight used in epidemiological studies are common possible predictors of disease outcome. Okay, so if the people or the subjects of study comes assessed in a clinic, they are measured directly. Sometimes they're interviewed at home, they will self-report their height and weight. So what you want to do is essentially, you want to compare self-reporting versus clinical reporting. So if you draw, how do I get this? Okay, how do I put this? Hello, is my pen working? Okay. How to get this to be pen up? Oh, this is not working. Okay, so let's say let me just close this thing again and open. Let's see if it works. It doesn't work. Hello. Okay, anybody know how to switch this pen working? Pen. Hold on. Some technical difficulties here. Let me just figure out. And settings. See if it can work. On, pen alert, on, eraser, on, okay. Barrel, hover click. There's a top pen, sketch pad. Okay, seems to be running a little low on battery, I guess. Hello, respond. Okay, anyway, this pen doesn't seem to work at the moment, so I'm going to have a problem here. Okay, so when that happens, let's say you have self-reporting versus clinical reporting. So let's do our PowerPoint. See, hopefully PowerPoint works. Otherwise, I'm going to have a problem. Doesn't work as well. Okay, draw with touch. Yeah, I want to draw with touch. Hit pen. Okay, so let's say this is not going to work for now. No idea what's wrong with it. Okay, so what you have is, let's say you have a, okay, we have to go very slow today this time. That means your table, your data will be something like this, your subject. And then what you have is your, let's say your height. Normally people tend to, your weight, this is in clinic. Okay, and your weight, this is self-reported. So you have subject A, subject B, and so on. Okay, so what kind of test will you use? Let's go from the bottom this time. Jianing, what test will you use?
So you'll first use the F test.
Okay. Then,
Then the T test.
yeah, t-test, there are 3 different versions of t-test. So which one do you use?
This one will be the independent one.
Actually, this test, you use a dependent t-test. Okay, because you are actually comparing the person, whether it's the clinic reporting. Let me just find if I can do something with this pen first. Hold on. Okay, so what happened is it will be dependent t-test, because dependent t-test is also known as two samples t-test, because what you are trying to report is between the person's ability between clinic and self-reporting. Okay, so it cannot be a independent t-test. Um, you managed to get it? Okay, now it works. Okay, so let's try. Okay, let's get first. Do you know what is the difference between your, so there are 3 types of t-tests. Of t-test. Okay, so first one is your um, dependent t-test. And then there's actually 2 types of independent t-tests. Anybody know what is the difference? Okay, so Jianing, why not you let us know what's the difference between dependent t-test and independent t-test?
Is it independent T test is from two different population, but then dependent is from one population?
Okay, so what happens is, to some extent, yes, dependent t-test is not from 2 different populations, it's from 2 samples. So for example, when do I use dependent t-test? Okay, let me clear this. So when do I use dependent t-test? Or no, when do I use independent t-test? Independent t-test is also known as your 2 samples t-test. Okay, so for example, I want to find out, let's say I have 2 different chemicals, chemical A versus chemical B. If I want to find out, let's say my research question is chemical B giving, let's say, better growth rate or cell growth rate, cell growth rate than chemical A. This will be my 2 samples t-test. Okay, because in experiment, what you do is you have 2 jars or 2 petri dish. One you have chemical A, one you have chemical B. Correct? So let's say you have triplicates. Triplicates. Then you find out the result is your average of A, growth rate of for A, and average growth rate of B. Okay, so this will be using your 2 samples t-test, because your null hypothesis will then be the average of A equals to the average of B. That means there's no difference in the growth rate of both when treated by both chemicals. The alternate hypothesis will be average of A is different from average of B. Okay, so these are called 2 samples t-test or independent samples t-test. But independent sample t-test, there's actually two versions of it. Okay. Now, dependent samples t-test sample t-test is also known as your paired t-test. Okay. So let's say you want to find out very commonly things like is an exercise program useful or successful in reducing weight. So in this case, what you have is you have, let's say, subject A or the subject A all the way to some number. Okay. Then you have before weight and after weight. So you have a value here, a value here. 1, 0, 1, 1, for example. Okay, and so on. So after that, what you want to find out is you find out a difference. And then your null hypothesis is if the exercise program does not reduce weight, so the average of your difference is 0. That means there's no difference. Okay, alternate hypothesis means there's a difference. So far, so good. Do you get anyone's confused with these two versions? Okay, so your independent sample t-test and dependent sample t-test, you will get it clear in the first place. You can do dependent sample t-test because subject A gives you both before and after. Subject gives you both before and after. Okay. But independent t-test has also two versions. You have your equal variance or equal standard deviation and unequal standard deviation. Because here you have your variance for A and your standard deviation of A and standard deviation for B. To find out which version of this test to use, you use your F test for equality of variance. Okay. In your dependent sample t-test, there's no equality of variance. So having said that, let's get back to the situation here. So, okay, Jianing, let's try again. What is the test that you should use here?
T-test for dependent.
So it's paired t-test lah. Is it paired t-test? Is it called paired t-test?
Yeah.
Okay, because what you end up with is here you have subject. Okay, and then you have let's say clinic reporting, and then this is self-reporting. Okay, so this self-reporting of weight, yes, subject A. Maybe the clinic you measure yourself as 60.1 kg, but then you think that you are 59 kg, something like this. So it's to test whether do you actually know your own weight? Okay, so this is your dependent sample t-test, dependent, or what is called as your paired t-test. Then what will be the hypothesis? What is the null hypothesis here?
The directly measure is equals to the self-reported one.
Okay, so essentially the direct measurement equals self-reported. Normally in this case, what we have is we look at the difference. The difference, the average of the difference is equal to 0. Okay. The alternate hypothesis in this case?
The directly measure is not equals to self-reported. So that means that like the mu d is not equals 0.
Correct, not equals to 0. Okay. So essentially, if you remember from our last week, our PET t-test is actually going back to what we did last week as well. Okay, so okay, you'll see it clearly when we come to all the practice. Yep, so this is right. Okay, so let's look at question 3. Okay, question 3, let's try Jian.
Yes.
What test to use first?
Left tail t-test.
Huh?
Left tail t-test.
So is it one sample or two sample?
Two sample.
So where is your two sample?
Sigma 1 square and sigma 2 square.
Sigma 1 square? No,
Yeah.
no. Read
No.
the question again. Okay, from this tutorial onwards, it's actually tougher because you have many tests you can use already. Is this similar to the question last week?
Wait, so there's only one sample and the sample is to test whether infected with E. canis has lower white blood cell count, is it?
Okay, it's believed that person infected with E. canis have an average white blood cell lower white blood cell count. So here the general population have the white blood cell count of 7.7200 per mil or per microliter. So how do you construct your hypothesis?
Null hypothesis will be mu D equals to 0.
Where do you get your D first? What divide by what give you a D?
Wait,
Question 2, you have clinic minus self give you the D. But
yeah,
question 2, what minus what give you the D?
don't have.
Don't have then.
So it's just mu equals to 0.
Mu equals to 0. So your white blood cell count is equals to 0.
Oh, okay. Should be 7250.
Yep. Okay.
Then the alternative will be mu is lesser than 7250.
Yep. Lesser than 7250. So then what hypothesis should you use? What test should you use?
Um, wait ah. The Z test.
Z test?
Left tail Z test.
Left tail Z test.
Yeah.
You can use left tail Z test to some extent. Okay.
Mm-hmm.
But if you want to use T test, which version of T test will you use?
If you use T test, then it will be
This is actually correct as well.
for T test. Will it be the T test where both sigma 1 and the T test for 2 means where sigma 1 is not equal to sigma 2.
Where is your 2 sigma? How do you know the sigma for the general population in the first place?
But wait, it's But then if we don't know the sigma, then how do we use the T test to find?
You have all the patients, you have patient, Patient 1, patient 2, patient 3 gives you your white blood cell count. So you have numbers here. Can you find out what is the average white blood cell count?
Yes.
And then the standard deviation for the white blood cell count. Can you do that?
10.
Yeah, lor. Then you use this. Use the standard deviation for white blood cell count. But what do you know the population standard
No.
deviation for white blood cell? That's a problem.
No.
So what test do you use because you don't have that?
Do we use the t-test that assumes equal variance?
Assume equal variance. T-test assume equal variance. Okay, so t-test assume equal variance. You are using two samples t-test, correct? Which
Oh, but
is
this
the
only
two
got one.
samples? Yeah, we have one sample. So which is two sample? So this is wrong. Huh?
Yeah. Then what? How to use t-test though? I don't get it.
You just use a one samples t-test.
Oh.
Isn't this similar to what you did last week? Let's say, for example, I give you a research question that is the average weight of a packet of instant noodles equals to 80 grams. Isn't this the same type of question?
Yeah.
Yeah, lor. So how do you do this type of question? This is actually your last week's tutorial, your tutorial 5. Yeah, lor.
Okay.
Okay. So you have a few tests to use now. Don't mess up your tests, okay? Because
Okay.
from now on, you'll be learning all the different tests. Actually, you will not be learning all the different tests. You'll learn another about maybe 6 more statistical tests. So the end of the day is how do you read the question and do the test. Okay. All right. Okay, so let's go up. Hui Ping, so for question 4, what test do you use? What test do you use?
I use z-test.
Okay, you use z-test, correct?
Okay.
So what is the hypothesis?
No hypothesis like mu1 equal to mu2.
Okay, what is mu1? What is mu2?
Oh, A, like pawn.
So
A.
mu of pawn A equals to mu
Yeah,
of
pawn.
B.
Yeah.
So basically,
Then,
you're talking about the sample average is being the same. Okay. So alternate hypothesis.
not equal. So it's like mu A not equal to mu B.
Yeah, correct. Okay, then significance level, the alpha.
0.025. Because divide by 2.
Correct. So it's divided by 2, 0.025. Correct. Okay. Then what is your
Z.
Z value?
I got negative, but I went to put positive, so it's like 9.054.
Right, it's 9.05. Okay. So it depends on which one you do first. Essentially, I will use the mean of A minus the mean of B, because I'll put the absolute first. Okay. Then you divide by the population standard deviation of A over sample size plus population standard deviation of B over sample size of B. Okay, so you work it out. Essentially, this you take your 3 minus 3.2. Okay, this but absolute R naught. Then you end up here with 0.12 square over 0.1 square first, 0.10 square over 3 or over 50, sample size 50 plus, so sample size also 50, 0.12 square, so this is 0.2. Okay, so you get 9.05. Okay, then what is your critical value? Your
1.96.
yes, okay, so this is from 0.025 equals to 1.96. Now, do you reject or accept the alternate hypothesis here?
Reject.
Yes. Okay, so you rewrite the thing that since your Z is more than Z critical, reject null hypothesis and accept alternate hypothesis. So what does alternate hypothesis means?
Like there's a difference between the two fits that will affect the growth.
Therefore, there is a difference between the two feeds or two brands of feeds. Correct. Okay, very good. Okay, so question 5. In fact, it will be the same way, almost the same way of doing it. We have Jeremiah.
Hello.
Hello. So what test do you use?
T-test.
T-test. Okay, you use T-test. But T-test, you use one sample or two sample T-test or paired T-test?
2 sample.
Okay, two samples T-test. Okay, then do you use equal variance or unequal variance?
Wait.
Wait, okay.
Equal variance.
Let's say, okay, in this case, you use equal variance, right? But how do you know whether you use equal or unequal variance?
You do the F-test, right?
Okay, so let's do the F-test. So there are two sections here. Or let me just show you again. Okay, so this is how you look at it. If you want to do two samples t-test, okay, because two samples t-test, there are two versions, equal variance or unequal variance. The first thing is you have to decide whether the variance of A equals to the variance of B. Okay, so for this you have to do your F test for equality of variance. Okay, then if the two variants are, you cannot reject your null hypothesis, that means variants are the same, then you do your t-test assuming equal variance. Okay, otherwise, if your alternate hypothesis means that variance A is not equals to variance B, then you do your t-test assuming unequal variance. Okay, all right. So in Excel, there are actually two different methods. Okay. You can do your F-test using Excel as well. But in the tutorial question or in the physical calculation, t-test assuming unequal variance is actually not in your syllabus. All right. Okay, t-test assuming unequal variance is actually not in your syllabus. You can do it. It's actually quite easy to do. In fact, it's using the same method, using this exact same equation. Okay. So let's us do your F-test first. So Jeremiah, what will be your null hypothesis?
Sigma square for the sample with high protein is equal
Okay.
to the sigma square of the sample with low protein.
Okay. Low protein.
Yeah. Then alternative hypothesis is that the variance is unequal.
Okay. All right. Okay, continue. Then what will be the alpha?
Alpha is 0.1. But here we use alpha divided by 2.
Yes,
So
0,
it's
0.05.
0.5.
Okay, then how do you calculate the F-test? The F
You
statistic.
take the higher variance over the lower variance.
Okay, always take the higher variance, divide by the lower variance. Okay. Now, because the higher, it depends on which one is the higher variance, you may have to swap it. So what is the first degrees of freedom and second degrees of freedom in this case? Your F distribution have 2 degrees of freedom.
But they are both 30, right?
Yeah, both 30 lor. Luckily in this case, both 30 lah. Because it may not be both 30. And that will make a difference. Okay. So here, what is your F result?
1.117.
Okay, 1.117, about 1.2. Then, what is the critical value?
It will be F 0.05, 30, and 30, which is 1.61.
0.05, 30, and 30 is 1.61. Okay, let's go. Do we have the table here? Mm, 0.05, 30, and 30 is 1.61. Okay, let me just check. Where is this two samples test? Lectures. Okay, where are the tables? Okay, anyway, assume that you are correct. It's 1.61. Okay, now this is your degrees of freedom, first degrees of freedom and second degrees of freedom. So make sure you read the table correctly. Okay, it's very easy to misread the table. Let me just hunt down the table. Okay, the table is actually not in here. Let me go and find the table. Okay. Okay, your F distribution table. Okay, your F distribution table is actually not easy to read because it's a three-dimensional table. Okay, let me me just open page turnover. Okay. So this is what you'll see. First, you have to make sure that you get the correct F distribution table. Here is 0. So there are actually a few different ones. The alpha is 0.05. Then the next table is alpha 0.01. Okay. The third table is alpha 0.025. So make sure you read the correct table first. So in this case, we have to read 0.05. Correct? Jeremiah, you use this table, right?
But isn't 0.05 alpha divided by 2?
Okay. No, because you actually have the alpha is 0.1 already. So the new alpha is 0.05.
Oh, okay.
Because you're claiming that 10% significance now. Okay. So you take this. Then your degrees of freedom for 30, you find the closest. So 30 is this column. Then you find the rows. So the row will be 30 over here. Okay. So you use your ruler and you get this 1.84. Okay, so you're reading the wrong table. So in this case, this is actually 1.84. Okay, so where do you get 1.61, Jeremiah? Are you reading the different another table?
Yeah, I probably used another table.
Okay, let's try where do you get. So you use 0.01. Also don't have leh. This is 2 point something. I think you go to 0.025. Maybe this is 1.84. Let's try. Also don't have leh. Where is your 1.61? Okay. Now, what I have to show you is, please read the table correctly. For example, let's say at 0.05, my 2 degrees of freedom, let's say I have 10 and 12. So 10 and 12, first degree of freedom is 10. I go to 12. This is 2.75. Okay. If I swap these two, the two degrees of freedom, what on hell happened? Okay, so I swap as 2, 12, and 10. So now I go to 12 and 10. I get a different number, 2.91. Okay, so these two are different. In your F statistic, you have your sigma, let's say sigma A and sigma B. This is, we call it degrees of freedom 1, and this is your degrees of freedom 2. The numerator is for degrees of freedom 1 and the denominator is for degrees of freedom 2. Okay, so make sure you get this. These are a few things that you will end up with an error. Number one error is these two, you swap it. The second error is make sure you use variance. It is not standard deviation. Okay, so here is given you variance. If we give you standard deviation, make sure you square it. All right. So, okay, so Jeremiah, here you accept or reject your hypothesis.
I failed to reject, so I accept.
Okay, so you fail to reject your null hypothesis. You accept. What does accept means?
You assume equal variance.
Yes. Okay. So you assume equal variance, correct? Okay. So then you can do the t-test now. Okay, so what is your hypothesis for your t-test?
Null hypothesis is the mean between the high protein and low protein is equal.
Okay. Alternate hypothesis.
The mean of high protein is higher than mean of low protein.
High, yeah, because claim that you increase the weights, right? Okay, so mean of high protein is more than mean of low protein. Okay, so in this case, what is your alpha?
0.05.
Okay, why 0.05?
Yeah, 0.10, then divide by 2, right?
No, because it's two tail. Two tail you don't divide by 2. Or it's one tail you don't divide by 2. Only when it's two tail, then you divide by 2. Okay, because it's one tail. This is one tail. One tail test, we don't divide by 2 anymore. Okay. Alright, but doesn't matter. Now, after that, you calculate your t statistic. Okay, what is your t statistic?
2.07.
2.07. Correct. Anyone cannot get 2.07. Okay, 2.07 is actually a little bit much harder to get because there's actually a long formula. Okay, so you have your mu of, let's say, your high minus the average of low. Then what you end up with is you have to find out this S square pool. Because you use equivariance, it essentially takes almost like the average of the variance. S square pool, you multiply by sample size. Okay. So S square pool is another formula in which you have to calculate out. Now, S square pool, the formula will be your sample size minus 1, basically your degrees of freedom, multiplied by the variance. Okay, the sample variance. So, plus, it is n divide by sample size of, add up the two sample size, minus 2. Okay, so make sure you get all this right. Okay, what the hell happened here? Okay, so let's see. Okay. So you put all the numbers in correctly, you should get 2.07. That's fine. Then what you have for the degrees of freedom in this case?
Is it 60?
60, correct. Okay, because this is the degrees of freedom is actually this guy here, the denominator. Okay, so it's 60. So you minus off 2. Okay. Now, what is the critical value then?
It will be t 0.1 and 60,
Okay, which
which
is?
is 1.296.
Okay, so conclusion?
Reject null hypothesis.
Okay, you reject your null hypothesis. So you accept your alternate hypothesis, and what does it mean?
That the mean weight for the rats with the high protein is higher than low protein.
Yeah. Okay. So average weight on high protein is more than the average weight on low protein. Correct. Okay. So essentially, this is a 15 marks question. 15 marks question, F test will be 5 marks, and the T test version part will be 10 marks. Okay. All right. So you can actually use your Excel to do your F test and T test after that. Okay, it makes your life so much easier. But here we give you the summarized data already, so you have to do it by hand. If you give you a raw data, then you use Excel to do it. Okay. All right. So question 6. Let's jump all the way to the top. Benjamin.
Hi.
Hi.
Okay. So I did F test, then T test
Okay.
for 2
So
minutes.
let's settle your F test first. What is
Sure.
that?
Null hypothesis is sigma A squared is equals to sigma B squared.
A squared equals to sigma B squared. Okay, let's see A and B. Okay, so alternate hypothesis is
Sigma A squared is not equals to sigma B squared.
yeah, not equals to sigma B squared, and your alpha?
Alpha, 0.5, then I divide by 2.
0.5, then okay.
So it'll be 0.025.
Okay, so what is your F result?
2.778.
2.778. Okay, because this is your standard deviation, make sure you square it. So it's
Yeah.
50 square divided by 30 square. Okay. Now, what is then the first and second degrees of freedom?
First one is 12, the second one is 9.
Yeah, 12 and 9. Okay, because you take this, make sure it's in the correct order. Now, after that, you have your critical value.
3.87.
Okay, so critical value is your F, you need 0.025, 12 and 9 equals to 3.87. Correct. Then what is your conclusion?
We fail to reject the null hypothesis.
Yep. Why is it giving me so much rubbish? Okay. So you fail to reject null hypothesis, okay, which means that you assume equivariance. Yep. Okay, we settled that already. Then let's go to your T test. What's your
Okay.
hypothesis here?
Mu A equals to mu B for the null hypothesis.
Okay. Mu A equals to mu B. Alternate hypothesis?
Mu A not equals to mu B.
Okay. Okay, your alpha?
So I divide by 2, so it'll be 0.025.
Okay, good. Okay, then in this case, what is your degrees of freedom first?
21.
21, correct. So it's 10 plus 13 minus 2 equals to 21. Okay. All right. Okay, what is your T statistic?
Minus 3.907.
Okay, so you make sure you do the absolute, so you get 3.907. Okay, that's
Okay.
fine. Your S square pool should be 1814. Okay, because you get this, I know that you get the S square pool is correct. Your critical value?
2.080.
Okay, your T will be 0.025, 21, 2.080. Okay, then what is your conclusion?
We reject null hypothesis.
All right, reject null hypothesis. You accept alternate hypothesis, which means what?
Like there is a difference.
Okay, there's a difference.
Yeah, there's a difference. Yeah.
In the average weight of what animal is that? Birds on different on the two different feeds. All right, very good. Okay, so you are done. Okay, so question 7. Let's try Ding.
Hi.
Hi. So
So I
what
take,
test will you use here?
sorry.
What test will you use here?
Oh, t-test.
Yeah, I know t-test, but what version of t-test?
The when null hypothesis is, I mean, when it's not equals to the other one. Test for 2 means.
Okay, is it test for? Are you going to use dependent t-test or independent t-test?
Dependent.
Okay, so you use dependent t-test, correct?
Yeah.
Okay. Okay, if you say dependent t-test, also known as your pet t-test, you're right. Okay. Then in this case, what is your hypothesis?
Mean d equals to 0.
Okay, mu d equals to 0. So what on earth is d?
You let d be the weight after, then you minus the weight before.
After minus before. Okay.
Yeah.
Then the alternate hypothesis?
It's less than 0.
Less than 0. Okay. So after minus before, less than 0. Okay. All right. Then what is the alpha value?
0.05. Because
0.0.
it's one tail.
Yes, it's one tail test. Okay, so very good. Degrees of freedom?
9.
9, correct. Okay. Okay, so what will be your t statistic?
I got negative
That's fine. Negative what?
2.09.
Yep, negative 2.09. But normally we just change it to positive lah. So we get 2.09. Okay. How about the critical value?
So value minus 1.83.
Okay, so it's actually plus minus 1.83.
Must put a
Yeah. So in this case, do you accept or reject the null hypothesis?
you reject because it's less than the t is in the critical region.
Yes, okay, because your t is in critical region. Okay, because if you draw it out this way, your critical value on both sides, this value is 1.83 and this value is minus 1.83. Okay, if you have minus 2 point, you get this value here. This is a t value, this is a t value. Okay, 2.09 and this is minus 2.09. So it's actually in the critical region. So you accept your alternate hypothesis. And what does our accept alternate hypothesis means?
Sorry, what?
What you accept alternate hypothesis, right?
Oh yeah.
Then what does it mean?
That is greater.
Greater. So does exercise helps or not?
Oh. Yeah, exercise help.
Yeah. So exercise helps to reduce weight loss. Okay, so this is actually quite important, because why? This conclusion is 1 mark. If you never write the conclusion, you don't get a 1 mark. This is 1 mark. This is 1 mark. So 3 marks already. Okay, let me just write it. This is 1 mark, 2 marks. So this is 3 marks. Okay, 3 marks. Then after that, we go back. This is 4 marks. Okay, degrees of freedom is 5 marks. This is 6 marks. Okay, this is 7 marks. This is 8 marks. This is 9 marks. And then the formula you get it correct is 10 marks. So this is a 10 mark question. All right. So this is why the final conclusion is three whole marks. So make sure you have all the 3 components in. In this case, where do I allocate the 5 marks here? Let's say for the one that Benjamin gave. So 5 marks come from here. Okay. This is 1 mark here. Okay. So this is 2 marks. This is so to find the critical value is 3 marks already. This is 4 marks. This is 5 marks. Okay. So here, where do I get all the 10 marks here? This is 1 mark here, 2 marks here, 3 marks here. Okay. Then your degrees of freedom will be 4 marks, 5 marks here, 6 marks here, 7 marks here, 8. This is 8 marks. This is a 9th mark, and then this is the 10th mark. All right. So this is how you allocate the marks most of the time. So make sure you have all the components in. Okay, very good. Okay, question 8. Aha. Okay, let's try somewhere in the middle. Akil,
Yes.
okay, good. What test do you use for question 8?
T-test.
Yeah, of course, t-test. Please don't tell me t-test. Which version of t-test?
PET T-test.
PET t-test. All right, PET t-test. Okay.
H now is mu D equals to 0.
What is B first?
After minus the before.
Okay. Okay, so correct. Mu D equals to 0. Alternate hypothesis?
Mu D is more than 0.
More than 0. Okay, so because after minus before, it should be give you better results. Okay. Then what is your alpha?
0.05.
0.05. Do you divide by 2?
No, because it's one tail.
Yeah, correct. 1 tail. Okay. So here, what is the degrees of freedom?
It's 9.
All right. Since you have the degrees of freedom already, you can find your critical value.
So critical value is 1.833.
Okay, correct. 1.833. Okay, then you can find your t statistic.
2.41.
2.41. Very good. Okay, conclusion now?
Since this statistic is more than t critical value, we reject the H null at 5 significance level and accept H1. So there is evidence that having extra lessons help students to do better.
Okay. For what? Lessons help students score better. Okay, this is correct. Now, last year, is it last year? Yeah, last year we actually had this type of question, and we actually something like this, and we gave students this table. Okay. The question is, um, does wait, is there a difference between treatments? Okay, so we give here, this is treatment of rats. This is treatment rat 1, rat 2, rat 3, rat 4, rat 5, rat 6, and so on. Okay, so let's have 7 and 8 rats. Okay, so this is treatment A, treatment B. Okay, so here we have a weight. Maybe we say that is 50. Okay, say 100 grams, 102. Let's say some other numbers. Okay, so maybe 98, 91, 102, 100, 10, 105. This is, let's say, 110, 100, 97, 98, 100, 106, 102. Okay, this question, which test do you use? Just tell me the test you use. See whether you get it right or wrong. So let's try Tracy. Based on what you see. What? Louder?
Is it t-test?
Yes, it's t-test, but which version of t-test? Which version of t-test? So t-test, don't just say t-test. T-test doesn't mean anything. You have to say that it's paired t-test or 2 samples t-test first. Which one? Paired t-test or 2 samples t-test?
Is it 2 samples?
Alright, it's 2 samples. This is the correct answer. Okay, because the same rat cannot have 2 different treatments. And here, you have 1 rat that's missing. Last year, half of the class said use PET t-test, and what they use to minus off. Okay, you realize that something is wrong. But last year, actually half of the whole cohort did this question wrongly. Okay. All right. Okay, question 9. Okay, Maximus.
What? We use T-PET test.
T-PET test, okay? So
Yeah.
PET, okay. All right.
The null hypothesis is mu D equals to 0.
Okay, tell me what on earth is D first.
D is the what is D? The difference.
So it's before minus after, or after minus before?
After minus before.
Okay. Okay. Then alternate hypothesis?
Mu d more than 0.
Okay, mu d more than 0.
Yeah.
Why do you say mu d more than 0? Look at the question. Is it say that there is lower sugar, higher sugar, or difference in sugar? In blood sugar.
Difference in
Difference.
blood. Oh, that means it's not equal
Untitled
to
test.
0.
Yeah. Okay, so it's not equal to 0.
Yeah.
Just ask you for a difference. It doesn't care whether it's a higher or lower.
Mm.
Okay. So the food maybe cause higher blood sugar. Maybe the food cause lower blood sugar. We do not know.
Yeah.
Okay, so what is your alpha here?
Is 0.05 divided by 2. So you
Okay.
get 0.025.
Degrees of freedom?
9.
9, correct. Okay, so let's find out the critical value first, since you have all this already.
Yeah.
Yeah, now you're going to read the table again. No?
$2.262.
Yes, so it's 2.262. Then how about you calculate a t-statistic? What do you get?
4.97.
4.97?
Yeah.
How you get 4.97? Okay, so let's you get some error, but let's do one at a time. What is the average for D?
wait. I think I got 24/5.
24, which is what lah? Average of D, 24/5 is what? 24/5. Yeah, which is correct.
4.8.
4.8.
Yeah.
Okay. So how about your sigma of D, or standard deviation of D?
This one I took the sigma, the standard deviation of before, and then sigma deviation, standard deviation of after, then I minus it.
Cannot.
Is it like that?
Cannot. So here, right, if you have after minus before, so this is 1. So this is 3, and this is 1 minus 1, 1. So here is 5, 7, this is 23. Something is wrong with this guy. It's 1, 2, 13, and 7. Okay, so this is your D. What you need is to take this number and find out what is the standard deviation of these numbers.
Oh.
You cannot take the standard deviation of before minus standard deviation after. Okay. This is not. So this is definitely not the standard deviation of after minus the standard deviation of before. So just calculate again. So please, for those of you, this is wrong, cannot use.
Is it 7.52?
No. 7.52, you are taking the population standard deviation. So it's what you press on your calculator is the wrong button. You press your calculator, you press this n. This is the one that you press. You should press this n minus 1.
Wait, I don't know how to do that.
Huh? You don't know how to do?
Yeah, I don't know how to do that.
No, you're pressing the wrong button on your calculator. Because I do not know what's your calculator, I cannot help you. Even if I know your calculator. Okay, this is the problem that some of you will face. Do you still have the manual that comes with a calculator? Please keep the manual with your calculator because you need it. Okay, some calculator will say, okay, so this is population standard deviation. This is sample standard deviation. So there are actually two buttons for it. Some calculator will actually use this button, population standard deviation. They will use sigma n. Sample standard deviation, they use sigma n minus 1. Okay. Some will use population standard deviation as sigma, and then sample standard deviation, they use x. So I have no idea what your calculator looks like. Okay. Because why? Population standard deviation, the equation is this: summation of x minus x, mean of x, divide by n. Sample standard deviation is x I minus x, mean of x, divide by n minus 1. So there's this 1 and n minus 1. So Maximus, you have to try out. You're supposed to use this guy.
Wait, I can just type it in, right?
You can type it in,
Oh,
but
it's
then
gonna be
it's
very long,
going
right?
to
Oh my god.
yes, right? Every one you have to minus off 4.8, 4.8 or 4.9.
Wait. 1, 4. Oh, okay. Seven 0.63.
Yes,
Oh my god.
7.63.
Yes.
All right. Okay. You get 7.63. Then what is your T?
Wait. One point 989. 1.98.
Okay. How you get 1.9? Okay. What is your equation? Okay, what do you divide? Tell me how you calculate it.
24 over 5.
Why do you get
Divide
24 over 5?
for the D bar,
Okay, so
which is
it's
4.8. Sorry.
4.85 divided by
7.63
uh-huh
over root 10. Oh wait, is it 9?
10, 10, 10.
10, 10, yes.
And you get what?
1.98.
1.98. Okay lah, close enough lah. Okay, yeah, because you have if you never by right you're not supposed to round off. Okay, by right the answer will be actually 2.028. Okay, you're not supposed to round off first. Okay. So anyway, both of them come to the same conclusion. So what's your conclusion?
Since the test statistic is more than critical value,
More than or less than?
it's more than what?
Hey, 1.98 and here is 2.262 leh.
Wait.
You
Since
don't blur,
the
leh.
critical value is less than test statistic, you will set the
Critical
now
value is less than test statistic.
critical.
Critical value less than test statistic.
Wait, what am I saying?
Oh,
Since
I know
the
what you're saying.
critical value is more than the
Yeah, okay.
test statistic,
Uh-huh.
so you reject null hypothesis,
Okay, you reject now hypothesis.
which means
Okay.
there is a difference after taking difference in blood sugar after taking food.
Okay.
Yeah.
There is difference in blood sugar. Taking the food. Okay. All right. So correct. Okay, 2.262. Okay, so you can use your Excel. So basically, while you're doing it, I use your Excel and do your t-test. Okay, and then this is your t-statistic lor. This is the t-statistic. This is a critical value. All right. So in your Excel, if you go to your data analysis tab, there are 3 versions of t-test. Your paired t-test, 2 sample assuming equal variance and 2 sample assuming unequal variance, which you have done your practical, right, for this week. Have you done?
Yes, sir.
Okay.
Yes, sir.
So your F test for equality of variance is this. So you have done that, then you're quite okay. So the main thing is, please do not get yourself confused like our Mr. Boo just now. He got the correct answer but got himself confused. Okay. Okay, anyway, let's continue. Question 10 and question 11 just ask you what is the error. Okay, so let's look at that and find out what's all the errors that you can find. Okay. There are maybe a few errors. So Hugh, what's the first error?
In terms of errors, let me just
check. I don't think I got this far yet.
Huh?
Sorry, I'm just mumbling away. So I'm not very certain, but I think it's something to do with the hypothesis itself.
Okay, the hypothesis itself. So what should the hypothesis be?
He's basing because he based off the. It's based on the mean.
Right,
sorry,
is that?
I'm not very certain. Sorry.
Huh?
I think
So what should the null hypothesis be in this case?
given that he wants to find where the differences, I think we should have focused on being a more collective difference instead of the combined difference, total difference instead of just the mean by itself.
Okay, so what is the null hypothesis? If you are asked to write the null hypothesis for him, how do you correct for him? The null hypothesis is
HO in for
mu d equals to what?
I think it's sigma config versus sigma outbound or something.
No. Okay, first is he using the correct test?
He's using I can tell he's using t-test, which is.
Yeah. But is it the correct t-test?
I think he's using the wrong t-test. He's not using the dependent t-test.
So you are supposed to use the dependent t-test, which is actually the pet t-test. So you are using the wrong t-test. Correct. So this is the wrong t-test. Okay. Then what should be the mu d equals to?
The D should be the combined differences. DF would be. I guess T would be the standard deviation of the differences.
Is it equals to 0 or not equals to 0?
Okay, the differences. I think the first one should null should be equal to 0, and alternate should be not equal to 0.
Okay, so this is a part that's wrong. All right.
Yes.
Okay. Then, given all the results, do you accept or reject null hypothesis? This part here. Okay, so the main thing is actually the test is wrong. The test and the hypothesis is wrong. Okay. Although the conclusion still says that you accept the null hypothesis in this case, but because generally we are a bit, for diploma level, we are a bit kinder in the sense that if your conclusion is correct, we will still give you some marks. If you go to a university in future, once your hypothesis is wrong or your test is wrong, everything will be wrong. Okay, so if you have the null hypothesis wrong, the whole thing is just 0 already. It doesn't matter what you calculate. Everything can be right, but your hypothesis is wrong. Okay, so please be careful with that. So this is just to ask you what are the mistakes that these students have committed. Okay, so Hugh, do you actually understand what's happening here?
I think I have an idea.
Huh? What do you say?
Yeah, I think I understand.
Okay, you understand something. Okay, good. At least you understood something. Okay, let's go to the last question. Okay, the owner of supermarket wish to see whether the number of shoplifting incidents per day drop if the number of uniform security officers is doubled. So over 7 days, before and after. Okay, so let's look at that. Let's try. Okay, Heiko, what is the what is the null and alternate hypothesis?
Okay. Okay. Null hypothesis is mu d equals 0.
Okay, so what is D first?
What? Oh,
What is D?
the after minus before.
After minus before. Okay, fine. Okay, mu D equals to 0. Alternate hypothesis?
Less than 0.
Less than 0. Okay, mu D is less than 0. Correct? Okay. So why is there a need to record the days?
That's why I'm not sure. I just say to know which day has like the most difference.
Okay. The question is, which day have a more difference? Why do you think which day has the difference?
Like more people, so like
yeah. Correct. So the difference, the days affect the number of shoppers.
Mm-hmm.
So that is the thing. Okay. In fact, this is a classical problem. So if you work in hospitals in future, you find that Mondays, for whatever reason, there are more people reporting to A&E for cuts. Okay, somehow people love to cut themselves over the weekend. So what is the hypothesis test that you will use? Question C? Please don't tell me t-test. I'm going to kill you. Tell me what t-test.
Wait. Pair t-test.
Yes, all right. Pair t-test. Okay. So here says that analysis firm suggests that the hypothesis test may not be appropriate, that you suggest may not be appropriate. Why?
It may not be normally distributed.
Yes. May not be normally distributed. So this is what is not included in your chapters yet, but t-test, all the versions of t-test and all the versions of z-test actually assumes normal distribution, that your data is normally distributed. Okay. When the data is not normally distributed, by right, you cannot use your t-test. That will be the later half of the of your topics. So for example, when you do your non-parametric test, this is when the data is not normally distributed. Okay. It's much, much, much harder to use. Okay. So actually, in order to check for normal distribution, there is this thing called normality test. Hey, what happened to my pen again? Oh, does it run out of power? Okay. So let's say you perform the appropriate statistics and the p-value is 0.03744. Okay, so what conclusion can you draw at 0.5% significance?
P is less than alpha.
Okay,
so we reject
the null hypothesis
at 5%.
Yes. Okay. So basically there's a change to increase the security officers. There's a drop, but how about 1% significance level?
P is more than alpha, so we fail to reject.
Yes, correct. Okay, good. Okay, so let us go back to the true false questions? Okay. Just now you're hiker, right?
Yeah.
Okay. All right. So Sean, how about the first one, 1A?
Sir, the answer should be true.
Yes, true. And my pen is still dead. But anyway, let me. What did I do? Hello. Uh. Okay. So let's try. Yeah, the answer is true. Okay. All right. Question B. Ranjini. True or false? Question B. False. Yeah. Because you can have the test statistic as negative. Very often, in fact, half of the time you can have negative. Okay, so you just have to do an absolute. Okay, question C. Daniel, I don't think I asked you today.
True.
True. Okay, this is a question that a lot of you get mistake. The answer is false. Okay. Now, I would say this is a question that I generally will not give. This is playing of words. Same means that it is numerically equal. So F-test doesn't test that the variance of two samples are numerically equal. It tests whether they are close enough, statistically equal. So it's false. Make sense?
Yeah.
Yes, sir.
Okay, good. Okay, question D. Okay, Jeremiah have answered already. Which is your mic okay by now? Or you can type in the reply on the meeting chat for question D. Weiqi, are you there? No response. Okay, anyway. It doesn't matter. Okay, Ihan. D.
Is it false?
Yes, it is false. Alright. How come I always remember you as a female? I must remember you as a male. Okay. Question E. Grace?
False.
False. Correct. Okay. Alright, so what you really need to do is make sure that you don't mess up the test. And the next thing is I have to tell you is quite important is this. Okay. If you ever find that, for example, here, okay, if you ever find that, let's say, the statistic that you calculated is very close to the critical value, please check your answers again. Okay, don't round off. Usually, we are not that evil to get the statistic that is very close to uh, critical value. Okay. All right. What's wrong with my computer today? Okay. Somehow it's not functioning. Okay. So that's all for today. I believe that correct me if I'm wrong, I believe the next 2 weeks is your term break, right?
Yes, sir.
Okay, so there's no tutorial. So please go and revise back everything. I think some of the later tutorials catch up with the tutorials that you need to revise again and go on to the next lecture. Okay, we when we read the or rather we watch the lectures that you have missed out or those that you do not understand because things get tougher and tougher from now on. Okay, All right, that's all for today.
Oh yeah, teacher.
Yes, what?
For the lab assignment, right, you are supposed to assign us the questions, right?
Ah, yes, I totally forgot about it. Okay, so now my computer is stuck. I can't even do anything. Okay, let me see. Delete. Okay. So let me. It's very simple. Let me just do it here then. Okay, Word document. This is what happens when I opens too much rubbish. Okay. Document. Okay. No. Okay. How come I have so many Chromes open? Okay, doesn't matter. Okay, lab assignment. Let's go to our lab assignments. So how many questions am I supposed? Well, how many questions are there?
4 in total because it's 2 main questions separated into 2 parts each, and you need to assign at least at most 5 people to one part, I think.
Okay, doesn't matter. So let me just get your names. Okay. There's 19 of you here, so let's try. Wei Qi, Benjamin. Can you see my screen?
Yes, we can see the Microsoft Excel sheet, sir.
Okay, so let me just find insert. So this is your name. Being Felicia. And Grace. Kunara. Let me see who else. Kunara. After that is Hugh. Hugh. How to spell Hugh? Hugh. Hugh Lin. Tracy. Tracy what? Low. Low. Yeah. So that will be Maximus. Maximus. Who?
Oh, we also got Zoo in our class.
Who? Oh yeah, what
We
happened
also
to
got
Zola?
Zoo in our class.
Doesn't matter. Just let me finish the name first. Maximus. Who? Okay, I just realized who is. I just go and search and who found Maximus was originally a king. So Akil, Heiko, Sean, Dan, and who else? Ranjini, Jeremiah, Hui Ping, Jianing, and Zhu. So we have 19 of you, right? Is that correct, Tracy?
Yep.
Okay, so questions. 4 questions. So which are the 4 questions that I have to choose for you?
There's 2A, 2B.
3A and 3B, right?
2A, 2B, 3A, 3B, sir.
That's all right. Okay, so 2A, 2B, 3A, 3B. So 2A, 2B, yep, 2B, 3A, 3B. Okay.
Sure.
What?
My name is not inside.
What's your name? Oh, Danielle, correct. Lost you. Danielle. Okay. Okay. So simple. So let's say, let's just do a random between top and bottom. 1, 2, 4. So pray for your luck. Okay. So this will be your options. Okay. So for 1, let me just sort this out. questions, smallest to largest. So this will be doing all the two A's. Two A's. So you have these are the two A's. These are the two B's. These are the three A's. And then these are the three B's. Okay, three B's, how come I have so many? Okay, so three B's. Okay, I got a bit too many three B's already. So anyway, I probably have to. Okay, I use all my. Okay, so now I have another two to slot to two B's. So let's slot to this. I change to 2B and continue to 2B. So this will be 2B will be 2. Okay, good. Okay, so these are the choices. Happy? Any violent objections? Make sure you tell Zul that he's on 3B. Anyone that I missed out? Any violent objections? Say now or maintain your silence forever. Oi, okay? If you're okay, just raise your hand. Make sure you know your questions. So go and come and nag at me later for posing you a different question. So save. This will be my coursework. Scripting. Lab assignment allocations for this is TM2. Okay. So these are the questions that you'll be doing. Cut, and paste. Okay, let me see if I can do something. Okay. So while we are at it, let me just see if okay. Announcements, lecture, tutorial, lecture, course materials, online test. Let me see, do we have lab assignments? Okay. Edit mode is off, edit mode is on. Let me see if I can do this. Build content item. Okay. This is the video assignment, right? Correct? Am I wrong? Right.
Yes, there's a video assignment.
Hold on. Okay. The question is, I want to see. This is a lab assignment. So lab assignment. Okay. Let me see this. Do I get the correct thing? Okay, lab assignment. This video assignment, you can do it. Primary. Okay, demo. This is what I've done, so you should be able to follow. Okay, all right. Okay, video assignment. And I believe that for a lab assignment, this is what you have attached file, video assignment. Okay. Let's see what the assignment says. Oops. Okay, the video. Okay, so question 1 is compulsory. This is recordings, video recordings, video recording, video recording, video recordings. Okay. Assign one question, 2A, 2B, 2C. Video assignment for allocation for TM2. Submit. Ta-da! Okay, so if you're confused, this is your assignment. All right? Happy?
Yes, sir. Thank you, sir.
Okay, that's all for today. Have fun.
Sir.
What?
Sir, may I ask, with regard to tutorial 6, question 11, B 11B,
question tutorial 6.
About explaining why there's a need to record the day. Sir, if we wrote the answer as this is because the comparison of the data for before and after each day of the sample of 7 days will be much harder if the day is not recorded. Would that be an acceptable answer as well, sir?
No. Because what happened is, the main thing is the number of people coming to the shops are different. So if you do not know which day, it's going to be a problem as well. So recording of days actually makes it easier for you to take before and one up minus the other.
So we should just write the answer as the days will affect the number of shoppers.
Yeah, that's the easiest way. Okay. And Sean, you have a problem with trying to explain too much. Just based on that sentence, please go and cut down the number of words that you're explaining. You have a lot of redundant words. Okay.
Yes, sir.
Okay. All right. Any more?
So just to clarify, for question 6 of the tutorial, when we are calculating the F critical value using the F table, so can we write the order of the degree of freedom as F, then 0.025, comma 9, comma 12.
Cannot. Because the 2 degrees of freedom is not swappable, remember? This is where I keep mentioning just now.
But then in this case, when we write down the degree of freedom, we should write out like cage A first, then cage B, right? So cage A is the first sample.
Not necessary, depending on the numerator and denominator. The numerator is the first degree of freedom. The data for numerator gives you a first degree of freedom 1, that's 12. Denominator gives you degrees of freedom 2. It doesn't matter the order here. So it can be swapped. So make sure you don't get it wrong.
All right. Yes, sir. Thank you, sir. So another. May I ask, when we are calculating the z value with the formula z equals to x bar 1 minus x bar 2, then minus the mu1 minus mu2, then divided by the square root of sigma square 1 divided by n1 plus sigma square 2 divided by n2. So is it correct to say that the mu1 minus mu2 is always equal to 0? The
Not
mu
necessary, but okay. Usually we don't bother about it. So the whole Z, right, will be you have your 1 minus 2 minus,
mu1.
okay. Then you have your division by something else. Okay. What this is your hypothesized mean difference. Usually is 0, may not always be 0. Okay. In fact, these two numbers, you actually, when you do in your Excel, the hypothesized mean difference, let me see. You see, this is the part that you put inside here. The hypothesized mean difference is the mu1 minus mu2. Usually we say that it's 0 because, yeah.
Oh, yes, sir.
Okay, so you always have that. We can even say that things like this. Okay, let's say H0, that the average of A equals to average of B. Okay, one is the average of A is not equals to the average of B. In this case, mu1 minus mu2 is actually equals to 0. But there can be a different case whereby I say that the average of A minus 5 is equals to the average of B. So the average of A minus 5 is not equals to the average of B. In this case, you say that mu A minus mu B is actually 5. Okay, which is something I say. Remember just now we have a question on whether does extra class gives a student better results. Right? I
Yes,
remember.
sir.
Okay, I can even state my now hypothesis in such a way that if the extra class is not improving the average student marks by 5 marks, the extra class is actually useless. Okay, so that will be the hypothesized mean difference. That means I'm actually putting that 5 marks into the question itself already.
Oh, yes, sir.
Yeah,
Yes.
it's just comparing those students who wants to come for the extra class has already determined to work harder. So by that very fact, whether he come for extra class or not, he should get 5 marks more already. Just by him or her working extra hard by himself. That's the usual case that we make it. But most of the time we try not to make it so complicated.
Oh, yes, sir. I see now, sir.
Okay. All right.
Thank you, sir. Thank you. Thank you so
Okay.
much. Thank you, sir.
All right. That's all for today. Have fun. Bye bye. See you 2-3 weeks down the road.